This is the review for the Algebra Regents for August 2017, the short response. So question number 25. The teacher wrote the following set of numbers on the board. So we have A, B, and C. Notice that A is the square root of 20. The square root of 20 is an irrational number. You can just type that in, big, long, ugly decimal, doesn't repeat, doesn't end. B is 2.5. That is a terminating decimal, so that's rational. And C is the square root of 225. Square root of 225 is a perfect square. That's 15 and negative 15. That is rational. So the part A sort of here says, explain why A plus B is irrational. Well, A is an irrational number. B is a rational number. Anytime that you add together an irrational number plus a rational number, it has to be irrational. As soon as it includes that irrational, it's going to be irrational. That always happens. So if you actually added those together, you get this big, long, ugly decimal. It's a non-terminating, non-repeating decimal. In the second part, but B plus C is rational. B is rational, C is rational. A rational plus a rational is always a rational number. All right, it always happens. If we did 2.5 plus 15, you get 17.5. 2.5 plus negative 15, you get negative 12.5. Both of those are terminating decimals, so it has to be rational. In question number 26, determine and state whether the sequence 1, 3, 9, 27 displays exponential behavior. Explain how you arrived at your answer. Yes, it does. All right, it does because anytime that you have a geometric sequence, it's exponential. All right, notice that the sequence, what we're doing each time is that we're multiplying by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So we're multiplying by 3 each time. So we're starting at the initial term or initial value of 1, but then it has a constant ratio of 3. So because it's geometric, because we're multiplying by 3 each time, it displays exponential behavior. In question number 27, use the formula for volume of a cone. Express R in terms of V, H, and pi. Anytime it says something like that, where it says express R, we want to try and get the R all by itself. We want R equals something. So there's a couple different ways to do this. I only showed one way, but first of all, you need the volume of a cone. You can find that volume of a cone formula on your reference sheet. All right, just like you have the quadratic formula on there and things like that, you can find the formula for volume of a cone. Volume equals 1/3 pi r squared h on that reference sheet. We need to try and get the r all by itself. So these terms are all being multiplied together. 1/3 times pi times r squared times h. So what we need to do is we need to divide by 1/3 times pi times h. Divide by everything except for the letter that you're solving for. So divide both sides by that. These 1/3s cancel out, the pi's cancel out, the h's cancel out. All that we're left with is r squared on this right-hand side equals v divided by all this gobbledygook. All right. We have r squared. The opposite of squaring a number is to take the square root of a number. So we want to take the square root of both sides. So you end up with a final answer of the square root of v divided by 1/3 pi h. There are other ways to do it. You could have multiplied by 3 on both sides first and ended up with a 3 in the top part of the fraction. You could have done that. You could have divided by each thing individually and had like a v divided by 1/3 divided by pi divided by h type of answer as well. All right, so there's multiple different answers and ways to do it there. This was probably the easiest way to do it. In question number 28, the graph below models the cost of renting video games with a membership in Plan A and Plan B. So you notice the lines for Plan A and Plan B. I think it's very helpful. Notice what I did down here at the bottom. I think it's very helpful sometimes to write in the missing numbers on graphs. All right, notice that I did that over to the side with 50 and 65 as well. I think that's very helpful. Explain why Plan B is the better choice if he only has $50. All right, so if he only has $50, we're looking at this red line right here. So when we're taking a look at that red line, Plan A, he could rent like 12 games. where plan B, he could rent 14 games. So if he only had $50, the best rental of them would be 14 games. You want more games, all right? You want more games for the same amount of money. So plan B would be the better one because you get 2 more games compared to plan A. If he had $65, which plan should he choose? Well, if you go up to 65 and go across, notice that these 2 lines actually cross right here. Since they cross right there, that's when the 2 plans are equal to each other. All right, that's when the 2 plans are equal. So which plan should he use? Well, both plans are the same, so it doesn't matter. All right, which one he does. No matter which one he does, he could rent 20 games for $65. In question number 29, she purchases a pack of sugar cookies. The nutrition label states that the serving size of 3 cookies contains 160 calories. So every time that she eats 3 cookies, it's a total of 160 calories. So we see at 3 cookies, it's 160. At 6 cookies, it's 320. At 9 cookies, it's 480, and so on and so forth. Explain why it is appropriate for her to draw a line through the points on the graph. Well, do you have to eat all 3 cookies? No, you don't have to eat all 3 cookies. You could eat 2 cookies. You could eat 1 cookie. You could eat 2.5 cookies, all right? But we're assuming that in each cookie, if you only eat like half of it, it's an equal amount of cookies or equal amount of calories on both halves of the cookie. So would it be appropriate to draw a straight line going like this? Yes, it would be, because she could eat 2 cookies, she could eat 1 cookie, and it would all be that partial amount because every cookie has the same number of calories. You don't have to eat cookies in multiples of 3. All right. Some people like eating cookies in multiples of 3, but you don't have to. This one is a hard one. All right. In question number 30, a 2-inch long grasshopper can jump a horizontal distance, that's side to side, of 40 inches. An athlete who is 5'9" wants to cover a distance of 1 mile by jumping. All right. If this person could jump at the same ratio of body length to jump height as the grasshopper, determine to the nearest jump how many jumps it would take for this athlete to jump 1 mile. So the first thing that I would do is this section in the green. We're talking about a 2-inch long grasshopper, but then the person is 5'9". First thing that you should do is make that all into inches. So 5'9", 5 feet is 12 inches. So 5 times 12 is 60 plus the 9 inches. So 60 plus 9, this person is 69 inches tall. So now that we're comparing inches to inches, all right, the 2-inch long grasshopper, this is where I'm getting this 2, jumps a distance of 40 inches. So 2 to 40. Well, I want to know what a 69-inch person, how many jumps that would take. So we would set up a proportion like this: 2 over 40 equals 69 over x. When you solve a proportion, you have to cross multiply and then solve whatever equation is there. So 2 times x is 2x. 40 times 69 is 2760. Divide by 2, we get a total distance of 1,380 inches. That's how much an athlete can jump. All right. So 1 mile. 1 mile is really 5,280 feet. Again, you can get that right from the reference sheet. So I want to make that feet into inches. So I would have to multiply the 5,280 times 12 to get 63,360 inches. To make that into jumps, all right, because that's the total distance of 1 mile. This is how much the athlete can jump. So the total distance divided by that, it's going to take 46 jumps for the athlete to go 1 mile. Notice that it said to the nearest jump. That's why I rounded 45.9 to 46. Does that really make any sense? No, but that's because the ratio to body height of the grasshopper jumps super far. All right. A human could not possibly jump 1,380 inches. All right. That would be very, very far. All right. That's like a quarter of a mile. All right. That'd be very, very far. So anyway, the next one, number 31, write the expression as a polynomial in standard form. All right, write the expression as a polynomial in standard form. So we want to distribute and distribute to get rid of the parentheses. 4x squared times 2x is 8x to the third. Remember, you do number times number, add the exponents. That's why it's x to the third. 4x squared times 7 is 28x squared. We now want to add together our similar terms. Add together our x squareds with our x squares here in the blue. And in the purple, add together our x's with our x's. Standard form. This is a super, super important concept. They have this all the time. Remember, standard form, you have to have your biggest exponent number first, then your next biggest, then your next biggest. If it doesn't have an exponent, these all do, but if it just had like a +3, that would go last. So in order with exponents, it would be 8x to the third plus 22x squared minus 4x. In question number 32, solve the equation. All right, so when we go to solve the equation by completing the square, the first thing that we need to do is we need to figure out what we need to add to both sides. We figure that out by taking half of the b term and then squaring it. So half of -6 is -3. Now we want to square that term. So -3 squared is -3 times -3, which is +9. That's what we need to add to both sides, all right? Because what we're doing is on this left-hand side, we're creating a perfect square. So now we have x squared minus 6x plus 9. 15 plus 9 is 24. Now you're doing reverse FOIL. You're doing reverse FOIL to this left-hand side right here. What times what is 9? That adds up to -6. It is a perfect square. That's what completing the square is. It's x minus 3 times x minus 3. We can write x minus 3 times x minus 3 as x minus 3 inside parentheses squared. The opposite of squaring a number is to take the square root of a number. So square root, square root. So now we have x minus 3 equals plus or minus. Remember, anytime we take the square root, it's plus or minus the square root of 24. Now we have to split the question. So we have x minus 3 equals the square root of 24. X minus 3 equals the negative square root of 24. Solve each of those. So add 3, add 3. We get the square root of 24 plus 3. Over here, we have negative the square root of 24 plus 3. You didn't have to simplify it, but if you did, that's okay. I simplified the square root of 24. That's really 4 times 6. So you would cross off the 4, bring out the 2. So it'd become 2 radical 6 plus 3. And on this side, you'd end up with negative 2 radical 6 plus 3. If you change them into decimals, I don't know what the decimal answer is, but if you change them into decimals, that would be perfectly fine as well. In question number 33, Loretta and her family are going on vacation. Their destination is 610 miles from their home. Loretta is going to share some of the driving with her dad. Her average speed while driving is 55. All right, so that's Loretta is 55. Her dad's average speed is 65. So dad is driving faster. The plan is for Loretta to drive the first 4 hours and her dad to drive the remainder of the trip. Determine how many hours it will take her family to reach their destination. So if Loretta drives the first 4 hours, we do 4 times 55. She's going to drive 220 miles. The destination is 610 miles away. So 610 minus the 220 that Loretta's driving leaves you with 390 that her dad is going to drive. If the dad is driving 65 miles an hour, you have to divide those two numbers. So her dad is going to drive for 6 hours. Now, notice the question says, how many hours will it take her family to reach the destination? Loretta is driving 4, plus the dad is driving 6. So it was going to take them a total of 10 hours. In the second part, after Loretta has been driving for 2 hours, she gets tired and asks her dad to take over. Determine to the nearest tenth of an hour how much time the family will save by Loretta's dad driving the remainder of the trip. So this time, instead of Loretta driving 4 hours, she's only driving 2 hours. So 2 times 55 is 110. Subtract that from the total trip. That means dad is going to drive 500 miles this time. So 500 divided by 65, he's going to drive for 7.7 hours. So Loretta's 2 hours plus the dad's 7.7 hours gives a total time frame of 9.7 hours. So 10 minus 9.7, how much time will the family save? So you need to subtract those two numbers. So your final answer is 0.3 hours that they're going to save. In question number 34, there's a lot of work going on here, all right? The heights in feet of the New York Knicks basketball players are listed below. What I would do first, anytime that you're given a table like this, type them into your L1, and if you had a second table, you'd type it into your L2. This time we just have an L1. So we want to do, all right, we want to do stat, calc, and one variable statistics. First thing that we need to do, however, is they want you to fill out this frequency table. So you need to take and make tallies and figure out how many of each there are. So for example, there are 3 numbers in between 6 and 6.1, because you have like 6, 6.1, and 6 from up here. I would cross them off as you go, just a suggestion. So you should have gotten 3, 10, 11, 0, 2, 3 as your frequencies. They want you to, based on your frequency table, draw and label a frequency histogram. A frequency histogram is just a bar graph, all right? If you only made the bars 1 bar thick instead of 2, nothing wrong with that. I just did it 2 to sort of fill the screen here. So anyway, this is what your bar graph should look like, all right? And then it says, determine and state which interval contains the upper quartile. By upper quartile, they mean quartile number 3. So if you do that, if you type them into your L1 and you do stat, calc, one variable statistics, it will tell you that your Q3 value is 6.5. All right, your Q3 value is 6.5. So which interval is it in? It would be in the interval of 6.4 to 6.5. If you could do this another way, you could put them in order from least to greatest, like I did here on the side. All right, and then your median is the middle number. The upper quartile, or Q3, is the median of the upper half. So your upper quartile is really in between 6.5 and 6.5. And so that would be 6.5. So that's just a different way that we can do it. Question number 35, very, very, very common short response question on the Regents exam almost every single year. Those of you taking the local final, you'll see this type of question, all right? Solve the following system of inequalities graphically on the grid below. Notice in the green part, they sort of throw something in here that we might have not seen before. Label the solution area, which is the double shaded area, with an S. They need you to write, see this black S right here? They need you in the double shaded area to write the letter S. Sometimes they ask you to do that on the Regents, sometimes they don't, all right? But the first thing, so you have 2 equations. Neither of them are in the correct form. We need to rearrange for y equals. So you need to get the y all by itself. In the first equation, in the red equation here, to get the y, 4y all by itself, we need to do minus 3x and minus 3x. Then divide by 4, divide by 4, divide by 4. Remember, you can leave the slope as a fraction. Notice that I left it as negative 3/4. If you wrote negative 0.75, absolutely nothing wrong with that. And then 20 divided by 4 is 5. So this is our first one. Now, when you go to graph it, you could do this in a couple different ways. Because you have the use of a calculator, you could type it right into the y equals and then do second in table to find your points. All right, you could do second in table to find your points, or you could graph it by hand. The slope is the number in front of the x, so that's negative 3/4. That really means down 3 over 4. The plus 5 here is your y-intercept. That plus 5 is 0,5. 0,5 is right here. So starting from there, you would go down 3/4, down 3/4, and then connect your dots. Because it is greater than is a dotted line, and you're shading above. Greater than is a dotted line shading above. Remember, it's a solid line if it has the or equal to in it. For the second equation, trying to get the y all by itself, I would get rid of the minus 18 first by doing plus 18 and plus 18, then divide by 3's. Notice that you end up with this equation, which is written backwards, all right? You always need the y to come first. So if we switch around the order there and switch it around so that the y comes first, you also have to flip the sign as well, all right? If you switch the side of the y, you have to flip the sign. So this is y is greater than 1/3 x plus 6. Again, you could type it into second and table to find your points, or you could start at the y-intercept, which is 0, 6 right here, and then go, this would be up 1/3. So up 1/3, put a dot, up 1/3, put a dot. It's a dotted line and we're shading above. Again, notice that they wanted you to label the solution S. That is the double shaded area here at the top. The question at the bottom says, is the point 3, 7 a solution in the solution set? Is this orange point right here an answer? Well, it's not. It's not because it's on the dotted line. Dotted lines don't include the numbers on that line. So no, it's not. Question 36, an Air Force pilot is cruising at an altitude of 9,000 feet. And here is the function that models the height in feet that the pilot is above the ground. Determine and state the vertex. Remember, the vertex is the turning point. All right, it's your max or your min. Explain what the second coordinate of the vertex represents. So what I would do is I would type this equation into your y equals. All right, type that equation into your y equals, and then find your max or your min. In this case, it happens to be a max, all right? You might need to change your window to fit the graph, all right? Notice that I wrote a little note over here. Remember about in Zoom, there's Zoom Fit, all right? When you go to Zoom and then Zoom Fit, that will help you get your graph totally on the screen without the calculator struggling to graph it, all right? So the max of this is 4, 9,256. So that's the max of it. Explain what the second coordinate is. That's the highest point. That's where the pilot ejected. All right. That's how high she went. All right. After the pilot was ejected, what's the maximum number of feet? She was above the aircraft's cruising altitude. So it says that the cruising altitude was 9,000. So you would just have to subtract those two numbers, 9,256 minus 9,000, and you get 256 feet. And the last one, Zeke and his 6 friends, all right, are going to a baseball game. So first of all, be very careful. When it says Zeke and his 6 friends, that is 7 total people. Their combined money totals $28.50. At the game, hot dogs cost $1.25, hamburgers $2.50, sodas 50 cents. Each person buys 1 soda. So they spend $28.50 on food and soda. So they brought $28.50 with them, and they're spending it all. So first of all, write an equation that we can use to determine the number of hot dogs and hamburgers his friends could buy. Well, first of all, you need to subtract out the amount that they spent on soda. So each person bought a soda. So 7 times 50 cents is $3.50. And then $28.50 minus the $3.50 that they spent on soda equals the $25. That's how much they have to spend on hot dogs and hamburgers. So hot dogs are $1.25. So $1.25 times hot dogs plus $2.50 times the number of hamburgers equals your $25 that's remaining. So rearrange for y equals, and we get y equals negative 0.5x plus 10. So you could go and graph that. What I would personally do is do a second and table to find the actual points. And you end up with this graph. I put hamburgers going up the side because that was my y. And I put hot dogs as my x. Notice that I had that right in the question. So this is what the graph of that would be. Determine how many combinations, including those combinations containing 0 of hot dogs and hamburgers, Zeke and his friends can buy, spending all $28.50. Explain your answer. Well, it would be 11. All right. Here's why it would be 11. It's a little bit tricky because when you start looking at these points for the number of hot dogs, all right, you can't go to a baseball game and buy half of a hamburger. All right. Some of these points, like if they buy one hot dog, they would have to buy 9.5 hamburgers. That doesn't make any sense. You can't buy a half a hamburger. If they buy 3 hot dogs, they would be buying 8.5 hamburgers. You can't buy it. So you're only looking at the ones that have an integer with an integer. All right. You're looking at integer and integer. So like 8 and 6 here, like 10 and 5, like 12 and 4, 14 and 3, 16 and 2, 18 and 1, 20 and 0. When you add up all of these purples, all right, when you add up all the purple dots, there are 11 of them. All right. So that's a little bit tricky right there. If you go through and if you kept track of your points, you could add up all of your points and see how you did. Passing on this exam was a raw score of 27 individual credits. You could just get that from 14 multiple choice questions, because remember, each multiple choice question is worth 2 credits, or you could get it from the short response